Hello and welcome to my new course of the CFD Analysis and CAD Modeling of the 5 megawatt NREL wind turbine. And in this course, we are going to use the latest version of the ANSYS 2024 release 1, as I am getting lot of requests to upgrade from like a 2020 to the new version. So I decided to change it to 2024 release 1. So the problem is that if you have the old version, this course, the commands will be maybe slightly different in terms of layout or the GUI, but the files you cannot use on your old version. So if you want to use my files, then you have to have the latest version. But anyhow, we will learn everything in here, so you don't require the my files as such. Okay, so we create everything in this course. Okay, so now you can see this is a CAD model that was generated in the SolidWorks 2022 the SP4 and ServicePack 4, and this is the wind turbine pressure control on the single blade. This is the hub region you can see, and these are the on the different sections like a Z20 12 meters, Z 19.5 meters, 30 meters, and 39 meters. This total height is 63 meters for NREL phase 6 wind turbine. Total height is 63 meters, and it starts from the around 6 meters. So this is when you talk about 12 meters, around maybe somewhere here. Okay, so these are results which you are seeing, and we will also be doing the same thing in this course here. Okay, so first the problem description and the objective. So for this course, we are going to study the NREL 5 megawatt wind turbine, and this is going to be the steady state. And the wind turbine type is the horizontal axis wind turbine. So horizontal axis wind turbine is a turbine whose axis is parallel to the ground. For example, for this wind turbine, the axis will be going through here, and the wind turbine will be rotating in this way. Okay. So this, because the axis of rotation which is here, this is parallel to the ground, that's why this is called the horizontal axis wind turbine. In short, it is the HAWT. So we don't require this to be the transient case. Why? Because all three blades, they will experience and they also interact in the same way, so they will behave similarly. So we don't require to be modeling it as a transient case. Although for some cases in like a higher angle of attacks with a high pitch angle, we do need the transient case because a lot of separations is happening there. But for these design conditions, we don't require the transient cases. But definitely for vertical axis wind turbines like WA, VAWT, because every time, at every location, the wind turbine is experiencing different conditions. So that is only possible to solve with the help of the transient method. Okay. So if you remember that there was, I will discuss that thing in the CFD modeling section. So first I will describe the wind turbine. This wind turbine is the 5 megawatt, and this is actually a baseline wind turbine. Why baseline? Because this wind turbine, this was this was from the Sheffield University wind turbine 6 megawatt, and then they scaled and they changed the height of the wind turbine and the chord length. So they scaled down to the 5 megawatt. Okay. And why they wanted to make the 5 megawatt wind turbine? Because there are the many cases where the 5 megawatt wind turbines are there, and secondly, it's easy to manage them from manufacturing point of view as well as from the transportation point of view. So that's why they stuck to the 5 megawatt wind turbine, and then they are disseminating this data to the research community so that they can study wind turbines through different methods. And definitely in this course we are going to learn the CFD method. So CFD is one of the technique or the field where this wind turbine is serving as a purpose for the study for the students and the professionals. So this serves as a design reference for the large wind turbines, And large wind turbines, now we can see that there are the large turbines at 7 megawatt, 15 megawatt, they are also coming into the operation. So we can actually, by studying this wind turbine, we can study the performance of wind turbines, large wind turbines, their reliability in the operation, and how they interact in the power grid. Okay, these all things actually we can study on this wind turbine. And so this is a test case used by the CFD community to address access different aspects of wind turbines. And these different things, not only limited to CFD, but we can test the different CFD algorithms and the turbulence models. And you can also perform the aerodynamic research in CFD or through some other methods to study compressed flow physics around the wind turbine, such as lift, drag, and turbulence. Wake modeling is a very important also. This may be affecting the environment or the nearby population, or maybe on the wind turbine farms. The one wind turbine farm wake is disturbing other wind turbines. And the loading analysis for structural modeling and noise protection, environmental impact, and maybe we want to optimize the wind turbine. So this wind turbine can be used for the optimization studies, and there are many algorithms available in the ANSYS also, which you can use actually to optimize the performance and make it further enhances its performance. And this is also serves the educational test case as we are doing right now. So just to give you idea that how wind turbines are progressing. So in 1985 the wind turbine size was 17 meter. That was very huge at that time, and it was able to produce a 75 kilowatt. Now it's a 30 meters in 1990 and 300 kilowatts. Now fast forward going to 1995, 2000, 1500 kilowatt, that is a 1.5 megawatt. And this is almost, I will give you idea that how they are related to the other things like Eiffel Tower, other things. And then let's move to the 2005, 3.6 megawatt, 100 meters height. And then 2010, 5 megawatt, 126 meters wind turbine, that is NREL 5 megawatt wind turbine, exactly this one. And in 2030 they are aiming for the 15 megawatt as the normal turbines operating. Mostly they will be offshore. Because why offshore? Because in the offshore these things are easy to operate as there is no human interference. Secondly, wind turbine speeds are wind speeds are very high and they are consistent because they're not getting disturbed from the nearby buildings and other things like the mountains, etc. So one is that we will be getting consistently high wind speeds and they are regular, so that we can produce the power for the more time. Okay, but now you can imagine that this is going to be 240 megawatt. This is 15 megawatt, and size is going to be 240 meters. Up to here. So you can see that the A380 aircraft, the size of A380 aircraft looks very small as compared to the these wind turbines. Okay, and the example is the different largest structures in the world. So starting from the Statue of Liberty, that's 93 meters. Okay, and this wind turbine, Heliade X, its height is 260 meters. We have the Washington Monument, we have which is at the 169 meters, Chancellor Building 319 meters, Empire State Building is 443 meters. This is still very tall as compared to wind turbines. Eiffel Tower is 324 meters, London Eye 135 meters, and the Big Ben 96 meters. Some more examples let me give you. For example, the suggested height of this wind turbine is 656 feet. And if you want to convert it into meters, that is we are comparing everything right now in the meters. So this is around 0.3. So converting them, we have to multiply the 0.3084. Okay, 3048. So it's a 199 meters. It's a 199 meters. In this case. Okay. So this 199 meter wind turbine height, this is not including the its radius. It's only height here. So now see the satellite space needle is a 060 feet, which is lower than this one. Then we have the Macken's Bilge Tower, 52 feet. Again, the Statue of Liberty is 305 feet. Okay. Now 305.3048 into 305, it's equal 92.93 feet. Okay. So now you can get the idea that how the wind turbines are getting. And the other wind turbine, that is, we are also going to get the around 15 megawatt power. Okay, there is expected wind turbine, that is the SUMR50, that is going to produce the 50 megawatt power, and that's definitely going to be like on the offshore. They can also be on the onshore. So it is bigger than even the Empire State Building. Okay, if you go on and take the more examples, you can get the idea here. This is 6 megawatt wind turbine. Okay, so if you go on, you will be seeing the different things here. This is last one. So you can see that Vestas launches 15 megawatt offshore wind turbine. And let's check the size of this wind turbine. This wind turbine size is its diameter is the like its height from the the surface of the sea. It's 150 meters, and diameter is 240 meters. So this is very huge wind turbine. Okay, the wind turbine we are studying has a diameter of 126 meters. So you can get the idea the size change between these two wind turbines. So you can see IEA wind turbine 15 megawatt. They are going to be on the on the offshore. Okay, very much sure about that thing. Okay, so this was a complete introduction about the course and the wind turbine. So now let's go to the second part.